Okay, so we're back on molecular compounds, and we have examples here. So we're going to look at molecular compounds a little closer. We have carbon dioxide, we have nitrogen dioxide, dinitrogen monoxide, nitrogen monoxide, water, H2O, dihydrogen monoxide. We have carbon tetrafluoride and phosphorus tribromide. Now, you don't worry about the names. That's not the important thing. The important thing that I'll show you, because you'll learn to name these later. The important thing we need to look at now is, okay, we have nitrogen and oxygen, carbon and oxygen, hydrogen and oxygen, carbon and fluorine, phosphorus and bromine. There's something similar about what type of elements we're bonding here. And you can already see down here, nonmetals and nonmetals. Carbon is a nonmetal. Nitrogen is a nonmetal. Oxygen is a nonmetal. Phosphorus, chlorine, fluorine, all these are nonmetals. And they are all, that's what they are all going to be in our covalent bonds. They are all going to be our molecular compounds. So our molecular compounds will always have a nonmetal and a nonmetal. Always. Metals and nonmetals will be ionic compounds. So that's the guys that we just talked about, the ionic compounds, are always metals and nonmetals, whereas molecular compounds will be nonmetals and nonmetals. So that's the way you can tell them apart, just by having their formulas written down. Now, a special type of molecule, I guess you can say, somewhat. This is going back to the monatomic. Now there's something called diatomic that you need to learn, and that's just a molecule consisting of two atoms, di meaning two. Hopefully you can remember that. And there are 7 diatomic atoms that you need to remember. We have O2, F2, Cl2, Br2, I2, H2, N2. So oxygen, fluorine, chlorine, bromine, iodine, hydrogen, and nitrogen are all diatomics. They like to pair up with themselves whenever they're found in nature. So they don't just, oxygen is not just an oxygen atom floating around. It's 2 oxygen atoms bonded to each other covalently floating around. So we look here, and an easy way to remember it is there's 7 of them. And so you look on the periodic table, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. That kind of makes like a 7. And then hydrogen plus 1. So hydrogen's the additional one. So you have the 7 and then hydrogen. Or, there's another way to remember these. There's a professor that these all make up. I gotta remember it. Professor, and hopefully this will help you. It helped me. Professor Brinkelhoff. Professor, so you can see all that. Professor Brinkelhoff. Brinkelhoff. I don't know. That's another way of remembering it. So if you can remember Professor Brinkelhoff or the 7 plus 1, those are all of your diatomic molecules. Or diatomic atoms. So that is not all for molecular compounds. We have more to do for molecular compounds. We are going to compare and contrast molecular compounds versus ionic compounds. We're going to look at the differences. So our first difference here, tilt this back a little bit. Our first difference, molecular compounds made of nonmetal and nonmetals. So just our nonmetals are going to make molecular compounds. Ionic compounds, you must have a metal. To be ionic, you have to have a cation and an anion, and so that means you have to have a metal and a nonmetal. Next thing, molecular compounds have low melting points and low boiling points. And ionic compounds have high melting points and high boiling points. So a good way to remember that. Sugar is a molecular compound. It's just made of carbon, hydrogen, and oxygen. So just carbon, hydrogen, oxygen make up sugar. Those are all nonmetals. It's if you put that in a pan on the stove, that will burn, that will melt. Salt, on the other hand, NaCl, sodium is a metal, chlorine is a nonmetal. Salt will not burn on the stove. You cannot get salt to burn on a stove. So, high melting point, low melting point. We go to the next one. Molecular compounds can be liquids and gases at room temp. So our examples are like H2O, water is a liquid, and the other example is C3H8, carbon nonmetal, hydrogen nonmetal. That's propane, which is a gas at room temp. Ionic compounds, on the other hand, are always crystal solids at room temp. And the example again is sodium chloride, table salt. It's a crystalline solid, so you're not going to have liquid sodium chloride just sitting around at room temp. Okay, so that's the differences between the two. You know about molecular compounds now. They're made out of nonmetals covalently bonding together, and that's section 8.1.